Welcome to this explainer. If you're running a factory or investing in global automation right now, you know the ground beneath us is shifting. We are seeing immense pressure from a massive influx of rapid, mass-produced machines. The industry is fundamentally transforming, and the rules of competition are being rewritten in real time. To really grasp this new macro reality, just look at the numbers. In 2024, China accounted for a staggering 54% of all global industrial robot deployments. That sheer volume is pulling the entire industry's center of gravity heavily toward affordability and mass adoption. Chinese companies are aggressively pushing the market with lower prices, massive scale, and incredibly fast product cycles. And sure, a low initial price tag makes it highly tempting for factories to buy and test these units. But strategically, we have to ask if this is creating a dangerous race to the bottom when it comes to long-term value. Because when we break down the total cost of ownership data, a harsh truth emerges. A cheap robot doesn't automatically mean a successful one. In fact, operational costs easily consume over 40% of your total budget over a machine's lifespan. That initial hardware purchase, it is barely half the story. The absolute crucial takeaway here is that purchase price does not equal real cost. The true financial burden sneaks up on you long after installation. It drains your budgets daily through power consumption, complex maintenance requirements, and, worst of all, the devastating cost of unexpected stops on your production line. This is exactly why we're seeing a strategic shift in how we evaluate robotics, moving from motion to operation. The old paradigm evaluated robots by how well they mimicked human movement in flashy, edited internet videos. But the new business paradigm asks a much tougher question. How reliably does that same robot operate on a continuous, gritty factory floor? This strategic pivot is exactly where Korea shows a distinct advantage. Instead of racing to make the absolute cheapest hardware, they are leaning into decades of established discipline in complex manufacturing. They're pulling the global focus back toward rigorous process control, quality management, and flawless execution. You see, Korea's strength is deeply rooted in its broader manufacturing ecosystem. We're talking about proven expertise in unforgiving environments, like battery supply chains, electronics assembly, and high-volume automotive production. Their competitive edge isn't just the robot, it's the highly sophisticated production system behind it, fully supporting an aggressive national goal to deploy 1 million advanced robots by 2030. Ultimately, the future belongs to factory-ready robots, not impressive standalone demonstration units. A winning machine actually has to fit seamlessly into the harsh ecosystem of a real production floor without disrupting the workflows you already have in place. So how do we spot a truly factory-ready machine? We can evaluate them using a pretty straightforward 5-point framework. It starts with operating hours. Simply put, a robot has to endure long, continuous shifts to deliver real, measurable productivity. If a machine needs constant breaks to cool down or recharge, it's a bottleneck, not a solution. Next up is power efficiency. We have to remember that every single physical movement consumes energy. Therefore, trajectory optimization and intelligent power management aren't just nice-to-have software features. They are core survival capabilities, especially for battery-operated machines trying to make it through a full shift. Then, we must look at maintenance speed. In an industrial setting, every machine will inevitably stop at some point. When it does, your true metric of success is how quickly preventive maintenance protocols and smart sensing technologies can diagnose the issue and get that robot right back on the line. Equally critical is factory integration. An industrial robot does not exist in a vacuum. It has to perfectly exchange data with your factory's digital brain, like PLCs, MES dashboards, sensors, and human workers, all to function smoothly within a tightly coordinated production schedule. Finally, the whole framework rests on lower downtime. Unexpected downtime is never just a technical glitch. It's a direct cause of lost output and delayed deliveries. In industries like automotive, a single minute of downtime can cost tens of thousands of dollars. Every second offline is capital lost. Which brings us to the core thesis of our analysis today. The true competitive question in robotics is shifting. The next stage of global competition will be decided by who can deliver reliable production capacity, not just camera-friendly movement. We are pivoting from mere hardware to true factory productivity. As one industry perspective perfectly summarized, the winner may not be the robot that moves best on camera. The winner may be the robot that keeps the factory running. The real long-term opportunity for manufacturers and integrators lies in deep operational know-how and flawless systems integration. I will leave you with this final thought. Uptime is robot intelligence. It is time to redefine what makes an AI robot truly smart in a global business context. Real intelligence on a factory floor isn't just about complex movement. It is about the relentless, reliable capacity to keep producing. When you look at your own production lines, are you investing in motion or are you investing in operation? Thank you for joining me for this explainer.